Hello, good evening, everyone.
Good evening, sir.
Okay, so today is week 8 session. I hope you have watched the lectures. Okay, so before starting the session, any specific query from your side? If you have any question, any doubt?
So, what is the weightage of week 1 to 4 and the quiz 2?
Weightage, okay. So by default, if we talk about the week 5 to week 8, so that actually inherit the concept of week 1 to week 4. Okay, so we will not ask any specific question from that week 1 to week 4 content. But by default, suppose if we ask any complexity of any algorithms which you have learned in week 5 to week 8, okay, content, but complexity is also discussed in week 2. So mainly the syllabus is week 5 to week 8, but inheritance is it also use some previous concepts. So because of that, we generally says that the syllabus is still week 8. Okay, but mainly is week 5 to week 8. Okay, so
Okay, sir.
hmm, yeah, any other query? Okay,
Sir, why it's going so fast?
why we are
Uh,
going so
there's,
fast?
yeah, there is so much time for weekend deadline.
No, where is the time actually? We only have the 1 week after this, and then you have quiz 2. Correct?
So,
And next week we will we will conduct a revision sessions only for quiz 2.
when is quiz 2?
3rd August.
Achha.
Okay, we don't have much time. Okay, so yeah, so week 9 will be released this week, and then there is no content in week 10, so that will be free. Okay, so in that you can manage your learning, and then OPP exam have syllabus till week 9, and there is only week 11 content. Then there is no content in week 12 also. So only this 10-week content is there. Okay.
Week 11?
Week 11 is there, but that is also theoretical week. That doesn't have any programming concept. Okay, that
Like a
theoretical.
revision kind of week.
No, no, no. We have the content for week 11, but that is not programming type of content. Okay, that is theoretical content. Week 12 is free. Week 12 is just we will release extra content. Okay, so that you can learn later also. That will not come in the exam. That is just a additional content. Okay, that is not in the syllabus. Okay, so any other query or shall we move to week 8 content?
So
So,
Yes, Neha.
I have a doubt in week 7 itself, why we are using Huffman code in real examples. Like, I'm not getting why we make it so complicated. Like,
Okay, Huffman algorithms you are getting complicated.
yes, sir.
Okay. I remember that in last week, I think, I'm not sure, in yeah, live coding session, I have discussed one example for that. Okay. So the one main example we can say that this is used for data compression. Okay, so as you know that when we transmit our data on network, we want that we want to send minimum number of bits. So that will take less time to travel, and that communication will be faster. Okay, so suppose we have one message. Let me just quickly give one example for this. Okay, suppose we have one message that have some characters, and each characters is repeating different number of times. And suppose we have one message like that contains these 5 characters A, B, C, D, E. Okay, and we have the different number of frequency for these characters in our message. So like this is repeating 100 times, and this is coming like 10 times, and this is 50 times, and this is 20 times, and this is like a 70 time. Okay, so we have total these number of frequency. If you add all these frequency, then how much you are getting? So 110, 160, 180, and then 250. Okay, 250 total characters we want to transmit now. And this message we have for 250 characters, and we want to transmit that. If we use some fixed coding for this, actually on the transmission line we can only send the data in bit forms, 0 1. Okay, so we want to convert these characters into our bit forms. So suppose we use a fixed coding method, and we fix the code length for each character, and we are just fixing, like we are using fixing 4-bit code. Okay, 4-bit code for each character. Then how many bits we required for this total to transmit this message? Okay, so just multiply all bits by 4, correct? Because we are representing each character by a code of 4-bit.
Yes, sir.
Okay, so now this become 1000. Total bits require 1000 to send this message of 250 characters. Okay, now other things, we can use a Huffman coding for this, that will generate a code for each character, and smartly this will generate the code for small code for the character which have high frequency, and big code for the which have the smaller frequency. Okay, so let's generate the Huffman codes for this. So how Huffman algorithms work? So that uses greedy approach. So to generate the Huffman codes, we generate the Huffman tree, and Huffman tree we use the Huffman algorithm. So according to the Huffman algorithms, we take two smallest weight every time, and we make a bottom-up tree. And let's 10 and 20 are the smallest weights currently. Okay, just see currently what are the frequency we have. Two smallest frequencies, 10 and 20. So we start from this, and we create a bottom-up tree for this Huffman tree. So 20, and this 10 is representing B, and this is representing D. Okay, now we added it. 10 plus 20 is 30. Okay, so this become a bottom-up tree structure. Now what are the remaining weights we have? So we have still, so this is now done and this is done. Okay, so every time we will only consider what frequency characters we have remaining and what total weights we are getting when we are combining the initial frequency weights. So 30 we have, 100, 50, 70. Okay, so 4 bits we have. I'm just writing here, so for the confusion, 100, 50, 70, these are the actual frequency, and 30 we are getting from the tree. Okay, so 30. So now again select two smallest frequency. Okay, so this 50 and this 30 will be selected. Okay, now 30 is already in the tree. Now 50 is the actual frequency of characters. So we will just make with this 50, and this is representing C. Okay, now we will combine these both. 30 and 50, 80.
80.
Now we have remaining frequency 100, 80,
70.
and 70. Okay, this 80 is already in our tree. So I'm just marking like this. And now we will select again two smallest. So 80 and 70, 150. Okay, so 70 we are taking as a new, 80 is already there. So again we will make this node here, 70, and we will combine them. So now 150. Okay, now we have remaining 100 and 150. Now we will select both, and we will make like 100, and we will combine this. So 250. Okay, so this top root value is representing the total number of frequency after combining all. Now we will make all left as by 0 and all right as by 1. Okay, 0, 1, 0, 1, and 0, 1. Okay, now 70 is representing E, and 100 is representing A. Now we will generate a code for each. Okay, so A, B, C, D, E. So just traverse from root to that node and see what digits are coming in that path on the edge. Okay, so for A, you can see only 1 is coming. So 1 is the code for A. Okay, B, for B, we have to traverse from root to this leaf. So 0 0 0 0. Okay, so 0 0 0 0. And C, so we have to come from this 0 0 and 1. So by this path, like this. Okay, so 0 0 1. And for D we have to come 0 0 0 1. And for E we have to come 0 1. So now these codes are called Huffman codes. And the one property these codes exist, these codes are actually prefix codes. So what's the meaning of this prefix code? So here, code of any character cannot become as a prefix of another character. Okay. So now you can see, just consider this is the smaller one. This complete code cannot become as a prefix of another code. Or this also cannot become as a prefix. Prefix means in the starting part of the another code. Okay, so one, you can see one is not coming in the starting part of another code. Complete 0 1 is also not coming. So this property is called prefix code. Okay, so now just check the length for each character. So the length for this is 1, this is 4, this is 3, this is 4, this is 2. Okay, now check the total number of bits required for this. So A, we required only 1 bit. For B, we required 4 bit. For C, we required 3. For D, we required 4. And for E, we required 2. Okay, now multiply this. So 100 and 40 and 150, 80 and 140. So now we are getting this 0 and 5 9 9 4 13 and 8 1 and 1 2 3 and 5. Okay, so total 510 bits we require if we generate the code using Huffman coding. Previously, if we are taking fixed code method, so we are getting 1000 bits, but now it is reduced to 510. So in this way, we can reduce our information or required data to transmit. Okay, so this is the one example where we can use our Huffman coding methods in the data compression. Okay.
So here A to E, we are sending through bits, and it will go through this process. Is it?
No, this is the message actually. We have the message. Suppose we have the transmitter
A.
T1 and T2. This is the transmitter and this is the receiver. We want to send this message. So message contains 250 characters. And these are the frequency for each character. And we want to send this message. Suppose we want to sending this message on the network with 1000 bit. Instead of we are sending the same message with the help of 510 bits. So which one is
So
efficient actually?
yeah, the Huffman one.
Because that is taking less number of bits and that will take less time to travel.
So the message will be A B C D E, like that.
The message will
Or a
be anything.
single.
Message will be anything, but of 250 characters. But the frequency of each character is like this. A is repeating 100 times. B is repeating 10 times. I'm giving this example. Message may be anything.
Like in a full sentence, if there are certain letters which are repeating, so
Yes, yes.
we will just consider once of each bits, right?
Yeah. Suppose if you are sending any message, how we will actually separate the characters at the receiver? We should have some type of coding method so we can actually decode that also. So we are first converting the text message to the that cipher message or some bit representation we are sending, but at the receiver that message should also be converted into the text form. So some distinctions should be there in the coding. So that if we are generating these codes with the help of Huffman coding, these can also be separated. They can be decoded easily because here the property is that these codes contain the property of prefix code. We can easily figure out that.
Sir,
Can it be A, B, C, or C, D, E? Like,
Message maybe anything. Message like A, B, C, A, B, C, A, like anything. So that
no,
250
I'm
characters.
saying like A is giving the 1 as value, B is giving 000
Huh.
as well. One of them is BC.
Okay, so I'm just writing one message like here. So suppose if I'm writing with the help of these coding, how we can figure out that? Okay, so like okay, so I've just written this message. Okay, this is generated with the help of Huffman codes. So I think in previous live coding session we have solved the problem with the help of this. If we have some message which is generated through the Huffman codes, how we can decode that? That coding problem we have discussed. So now this message there, how we can decode this? So for this, we have the coding. Okay, Huffman codes we have. So what code is represented by which character? So if we traversing this message, you can see we will take one bit from here and we will check if this bit is exist in our codes or not. Okay. So this is, or you can make the dictionary like you can just keep the code first and character as a value in the dictionary.
Sir, once I that is multiplied by 50 or though जो numbers are given.
Mhm.
So numbers are every time like we have to multiply with that.
No, this is depends on the question. Here, I'm just discussing data compression example. So I'm not asking. I'm just giving the example how we can reduce the bits. Your problem is discussed in the lecture till only to generate Huffman codes or Huffman algorithms. We have not taken any like use case for that, but we have discussed the some examples in live coding problems where we can use this. Okay, so I'm just giving the example. What is the benefits of this Huffman code or Huffman algorithms where we can use this?
How questions can come from this?
Okay, so the question maybe come from this. Like suppose if we just give the frequency of characters and we can ask, suppose this is the message A, B, C, D, E. Suppose this is the message, then how many bits are required for this total message? This type of question maybe come in the exam.
Bits are the ones that we have calculated the total bits of
Yes. So
A,
here you
B.
can see A is taking 1 bits, B is taking 4. So just add all these because this is single message A, B, C, D, E, all single character. So we are
What
just
510 is given? What is 510 is giving them?
510. No. This is we are not asking. Okay. Yeah. This maybe also ask. This may be the different type of questions. If we will ask that what is the total number of bits required for that message. Okay. So at that time you have to calculate like this. So based on the question, what that question is asking, you have to figure out that what you need to calculate.
Sir, if the code is given, then for say one of the letter is giving 100, and from that we don't understand how many numbers should we take to
So
get this.
I'm just giving the idea here. Okay. So
Okay.
suppose this code is given. How you can decode this? You have the set of all codes for characters. Okay, that we have already generated. Now just traverse this message one by one. Okay, so one bit by one. Take the one bit and check if this is exist at a complete code of any character or not. So you can see this is exist. So just represent this by a. Okay. Now take the second bit 0. 0 is exist at a complete code or not? No.
No.
If not exist, just append one more. Okay, so like 0, this one. Okay, 0. Check if 0 is exist. No. Now append one more. 001 is exist. Yes. Just replace this with by C. Okay, and again start from this 0. This is not exist, then 0. Not exist, 0. Still not exist, 0. 1. Okay, this is representing D. Again start from here. So 0 not exist, 0 not exist, 0 not exist. Now this 40 is exist. Okay, this B. So this become B. Okay, same thing we will repeat for each character. So 0 not exist, 1 is there. Yes, E.
Every time we look for the closest match.
Every time we will check that exists in our code session or not. Otherwise, we will append one more bits.
What if the bits are similar?
Bits are similar means
What if we say A is equal to 1 and A is equal to 0? Then
A is equal to 1 and A is equal to 0. How it is possible? We will get
no,
only
no,
one. Huh.
no. A is equal to 0
Hmm.
and K is equal to 0. Then which value will be put on?
No, you are saying A equal to 0.
K is equal to 0.
What is K here?
Sir, if both are means A 0, K
Okay,
0.
okay, okay. So this is not possible, no? So Huffman code cannot generate the same codes. As I mentioned that Huffman codes have the property that it will not generate. It will generate a prefix code. Prefix code means no one code cannot. So any code cannot become as a prefix of the another code. So here you are saying A is 0, B, K is 0. This is not possible by the Huffman codes. This cannot be generated. So here this 0 is as a prefix. So this is not possible. Okay. Here
Also,
in this Huffman tree, you can see each actual character frequency is coming at the leaf node. Okay. So here you can see B, D, C, all are the leaf nodes. And from root to leaf, only one path is possible. Correct?
okay.
If you are traversing from root to leaf, only one path is possible. What condition you are saying? A equal to 1 or K equal to 1? So that's not possible. You are saying that both are coming on the same leaf position. This is not possible in the Huffman. Okay, so you will get a code like this. So that code will be the prefix code. Okay, so you can easily distinct the code, identify the code.
So, if one of the letters is 100
Hmm.
and 0001 is also there,
Oh, one second.
the
One letter is 100 and another is
0001.
okay.
At the last part of this code, like A, C, D, B, E, the last part where we haven't gone, if we start from 100, like last five numbers.
This you are saying?
Yes. So will we take 100 and
No,
uh,
no. So what process we cannot directly jump in between. Na? So we will start from this side.
okay.
Okay, we will start from left to right. Now we will reach at this point. Okay, so 0 and 0 is not there. 0 is 1. 001 is there. Yes. So in this 001 is C. So here, what will be the come first? So 1 is there, then 0, 0. Okay, so you can see 100 is representing is not there in the above, but you have said that if it is happening here. So any one code will be matched. If your message contains message is created with the help of Huffman codes, you will never get this type of like ambiguity or like contradiction type of things.
Can there be codes which will remain after decoding, like for say 01 is left, but no letter represents 01. So what will
So
happen to that?
that is actually like a invalid code. So that means that code is not generated through the Huffman codes, or maybe that is corrupted.
Okay.
Okay, on the transmission, maybe that is corrupted due to some like attenuation or any error. Okay, so that is just a corrupted
Sir, this is week.
7 topic. Okay,
Yes, sir. Thank you.
okay, okay. So let's move to the Week-8. Where we have this. Okay, so Week-8 is we are discussing about the divide and conquer strategy to create algorithms. Okay, so this is also a algorithms design techniques, and this algorithms example you have already seen in the previous weeks. Okay, so as we have mentioned here, This merge sort, quick sort, you have already learned. But maybe at that time you are not aware of this divide and conquer terminology. Just give me a minute. I'm taking some pen. Okay, yeah. Okay. So here merge sort and quick sort. These example we have already taken. And what was the idea behind the merge sort algorithms? So the basic concept of the merge sort is first we break the problem. Okay. First we break the problem into half part. Again break the problem into again two half parts. So we break the problem until we will reach at the single element. Okay, on the label. After that we do the process, we compare the elements, and then we start the merging process. So because of that, this algorithm is called divide. Okay, so first term is divide. So that reflect break the problem into disjoint sub problems, and after that concur. So concur is a way just to combine the solution of sub problems. Okay, combine the solution of sub problems. So this is the method we used in this divide and conquer strategy. So merge sort we have, yes.
If the number of elements is even, then empty list.
Still it can be do. Okay, so this is not always equal. Like we have 5 elements. So like 4, 3, 6, 2, 1. We have 5 elements. So we can simply use the method like we just check the length and we will divide by 2. Okay, and we based on that we can check the index for dividing. So like here we have 5 elements, we will use the floor division. So like 2, and we will get 2. So this means 0, 1, 2, 3, 4. Where the 2 index is coming, we will break from there. Okay, so 4, 3, 2, 6 will come in the one part, and 2, 1 will come in the next part. So in this way, break will happen. Here we have 2 elements, here we have 3 elements. Again 3 floor division by 2, we will get 1. So 0, 1. This is the 1 index. So 4, 3 will come in one part, 6 will remain alone, and here 2 and 1. Okay, so 2 and 1 will break single. 2 and 1 like this. So this part is still remaining, so this will break again. So 4 and 3. So now this way break is happening. Now we after reaching at the last level, now only single elements are there. So in merge sort concept, we use the combined method here. Okay, so combined method means single element, we can say that this is sorted. Okay, so there is no element to compare for this. So this is a sorted list. We can say that this is a sorted list that have only single element. Now we will start the process to combine this. Combine this means we will use the merge method here. Merge method basically takes 2 sorted lists and combined into a 1 sorted list. So this is the merge method we use inside the merge sort algorithm. So this takes, I hope you know that how we merge that. Okay, so if we have 2 sorted lists, how we can merge that into a 1 sorted list. So from this position, combine method is used. So that will combine and will sort also. So 3, 4. Okay, now this will become, and this will return back to this position. Okay, so this sorted list is now written 3, 4. Okay, so now 3, 4 and 6. This side is 6. So now this 2 part will merge because 3, 4 is already sorted and 6 is also sorted. Now again we will combine. So now 3, 4 and 6, you will get a 1 sorted list. Same things will happen on the other side, and that problem is solving separately. Okay, so we are not comparing at this level this 2 with on this level. So each sub problem is solving separately. These sub problems are not interfering at the each level. So 2 and 1 will combine at this point, and it will become 1 and 2 sorted list. Okay, now you are getting 3, 4, 6 1 sorted, and 2 and 4 1 sorted. Again you will merge here, and you will get a final sorted list. So in this way, this merge sort actually works. And similarly, we have the quick sort we have discussed. So quick sort basically takes one pivot element, okay, that you can take either first element or you can take either last element. But after doing the process, that partition process, okay, so in partition process, we arrange our elements in this way. So that pivot position will come at the actual correct position of that, okay, in the sorted order. But before pivot element, all element will be shifted all sorted smaller element will be shifted before that, and all greater element will be shifted after the pivot. So this process happen in the partition method. So that takes order of n time, and we can do this process in just a one linear loop with the help of one linear loop and just comparing, and then we can shift the positions. So all small element will come before, and all great element will come after pivot, and pivot will come at the actual correct position in the sorted order. In this way, we will just take the left part, which is still unsorted, right part, which is also maybe unsorted. So we will apply the same quicksort method on left and right part. Okay. So this is the way of quicksort, how quicksort works. So that also actually break the problem into half part, but that apply first partition process and then break. So in this way, that also sort become a sorted list. So that also use the divide and conquer approach. So these example you have already seen previously in week 2, week 3. Now comes to the next examples, which is covered in the week 8. So here, first problem is discussed, counting inversion. So what is the counting inversion, and what is the definition if we see? So here, if we have some sequence like for 1 to n number, so like I'm taking the example, what is the counting inversion we are saying here? So like we have some random number like 6, 4, 1, 3, 5, 2. Okay? Like this number is given, and we want to find the counting inversion for this. So you can see the definition. And so here indexing is there. So okay, 0, 1, 2, 3, not 3, 4, 5. Okay. And if you just write a corresponding sorted order for this, so that will come like a 1, 2, 3, 4, 5, 6. So this is the sorted order. So we will relate. So an inversion is a pair I comma j, where I is less than j, where j appears before I. Okay, so what is the meaning of this? For each pair we will check this. So you can see 6 and 4, just check this compare. So 6 and 4, 4 is smaller than 6, but 4 is coming after the 6. So that is a one inversion pair. In the sorted order, this 4 should come before 6, correct? But here the order is not correct for this. You can see in this 4 is coming before 6. But here in this actual list, we are getting inverse order, which is not in the correct order. So this is representing 6, 4 is representing one inversion pair. Similarly, if you check 6 with 1, still this is also a one inversion pair, because 6 should be come after 1. So 6, 1 is also a one inversion pair. 6, 3 is also one inversion pair. 6, 5, okay, 6, 2. So all these are actually inversion pair. Same we will check from 4 or 1. So this is also 1. 4, 3, correct. Okay, 4, 5, this is in correct order. So 4 and 5, this is in correct order. You can see 5 is coming after 4. Here is also 5 is coming after 4. Okay, 4 and 2, yeah, this is one inversion pair. Now same 1, yeah, this is not making an inversion pair with any elements. So 1, 3, 1, 5, 1, 2, all are in correct order. Now 3 and 5, yeah, 3, 5 is correct, but 3, 2 is making one inversion pair. 5, 2, this is also making one inversion pair. Okay, now 2 is single. So you can see if we are comparing each pair, each possible pair here, which one is making actually inversion. So these are the pair in this list that are actually in inversion pair. So how many are there? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can see that the how many inversion pair in this? 10. And this inversion pair counting is actually represent the similarity corresponding to the sorted order. So how much this actually similar to this, to the sorted order? Okay, so actually we have this list, but if we are comparing to this corresponding this sorted order, so what is the similarity of this? So still here we have this 10. So that means if inversion count is less, so that means those two lists are actually more similar. If inversion count is big, so that is actually more dissimilar.
Sir, why
Yes.
they have not calculated for inversion pair for 1, 2, 1, 3, 1, 4, 1, 5, 1, 6?
Why we calculated this?
No, why we haven't calculated as a 1 in, like we have
Uh,
calculated,
so 1 3 you are saying?
yes, 1, 3, 1, 5, 1, 2.
We have checked it, but these are coming in the correct order now. So 1 3. Here 1 is coming before 3. In sorted order is also 1 is coming before 3. So this will not count as an inversion pair.
So we want the pairs in descending order. No?
Hmm. So when we are comparing, so if in the comparison list, if the order is same, okay, so we not count it as an inversion pair. If order is different, okay, then we compares. Okay, so 1 and 3, these are in correct order. Okay, 1 and 3. And here 1 and 5, this is also, you can see this one is coming before 5.
We
Here
have
is
to
also,
calculate the wrong order.
wrong order compared to the another corresponding list.
So what about 5 3?
No, take from the same order. Na? So why you are taking 5 and 3 like this? We are taking from this side, left to right. So 3 is coming first, na? 3 and 5. Check
We have
this.
to compare the box into like in a sequence.
So just check the definition. An inversion pair is a pair I comma j. Okay, so I comma j. So these are just a value. Okay, where I is less than j. So this is the condition. I is less than j. But j appear before I. So but this is coming before I. So this is called as an inversion pair. Okay.
Sir,
Huh.
what is the use of it?
What is use of it?
Can do by counting inversions.
So as I mentioned that this represents the similarity of two different orders. Okay. So if inversion pair is less, so that means those order are much similar. Okay. So I'm just giving the example here. So how we can just check two orders. Suppose here Professor have also discussed the ranking things. Okay. So if we are giving the ranking for 5 movies. Okay. So like, sorry. We have suppose 5 movie M1, M2, M3, M4, M5. Okay, so one user is giving the ranking for this, like how much that user likes that movie. So that this movie likes that one. Okay, and this is 2, this is 3, this is 4, this is 5. Okay, so one user giving this ranking for these 5 movie. Okay, so another user like user 1 is giving this, and user 2 is giving the another like ranking. So suppose this is the one, okay, and this is 2, this is 3, this is 4, this is 5. Okay, so these rankings are given by two user on this movie M1, M2, M3, M4, M5. So how much these rankings are similar? Okay, so we can identify the similarity of these two different ranking by two different user by this inversion pair. And how we can give this? Here you can see here we can simply check the inversion pair of user 2 correspond to user 1. But how we can check this? Okay, here order is different for both. Here order is not given sorted, but we can just like give a mapping for that. Okay, so how we can just generate the mapping? So just give the mapping for user 1. Okay, so I'm just giving the mapping like this. So I'm just giving the R1, R2, R3, R4, and R5. Okay, just use this base number. Okay, so this is, you can see, is given as a increasing order 1, 2, 3, 4, 5. Now I have just mentioned this R1, R2 for user 1. Now I can just check of the user 2 ranking how much this is similar to the user 1. Now for the same mapping, I will just identify the ranking for user 2. So you can see for 3. So for 3, what we have marked 4, correct? So I just give the R4 here. Okay. For 1, what we have marked here? 3. So R3. And for 2, we have marked R2. For 5, we have marked R5. And for 4, we have marked 1. Okay. Now just compare these two. Okay. So now I'm just writing U1 is R1, R2, R3, R4, R5. Okay. And now user 2 is R4, R3, R2, R5, and R1. Now you can see you are getting, this is the sorted order 1, 2, 3, 4, 5, and this is the 4, 3, 2, 5, 1. Now you can identify the count same way, in the similar way which we have calculated before. So like 4, how many count, inversion count is generating from this? So just identify that after this 4, how many elements which are lesser than this. So that will generate a one count. So 4, 3 will generate, okay. So 4, 3, I'm writing here 4, 3, 4, this is 2, okay. 4, 2, 4, 1, okay. These are the inversion count. For 3, 3, 2, and 3, 1. For 2, 2 and 1. For 5, 5 and 1. So these are the inversion count when we are comparing user 2 correspond to user 1. So 1, 2, 3, 4, 5, 6, 7. So 7 count we are getting. How many maximum possible for this? If we have 5 numbers, how many maximum possible? And how many minimum possible?
Maximum 10.
Yes, maximum 10.
How you got this?
N into n minus 1 by 2.
So examples, we can simply maximum case is like if we are getting reverse order like 5, 4, 3, 2, 1. This case. So 5 will generate 4 inversion pair this. Okay. So 5 will generate 4 inversion pair. This 4 will generate 3. So 3 inversion pair, and 3 will generate with 2, and this 2 will generate with 1. If you add this, you are getting 4 plus 3, 7, plus 2, 9, plus 10. And if you can get this number maximum with the help of n into n minus 1 divided by 2. Okay. So 5 into 4 divided by 2, 10. So this is the maximum possible inversion count. Okay. What is the minimum?
0.
0. Okay. If both order are the same, so that is the minimum. So in any given order, so we can figure out that how much that similar are. So if you are getting 0, okay, so that means that are exact similar. If you are getting 1, so this is also very, very similar. If you are getting 10, so this is maximum dissimilar. So based on that, you can figure out that so how much user rankings are similar or not. And these Netflix, Amazon, all these actually use this algorithm to give the recommendation. Okay, suppose if you are watching any movie, so based on that, sometimes that also reflect another movie which you may also watch. Okay, that means so they checks your interest and they match your interest with the another user interest and what other user have watched. Okay, so they will also suggest for you. Okay, so yeah, so like movie suggestion, friend suggestion, so like your social media platforms, you also got that friend suggestions. Okay, so this may be your friend, this may be your friend, so you can just check how you know that, and you send the friend request like this. So that also use this type of approach. They check the similarity. Okay, so recommendation, movie recommendation, this is one example of this very and these are very like most common example for this which are using on the most OTT platforms. Okay, they are just checking your interest and they suggest some additional movie which you also want to watch. Okay, so this is one application which is using.
Yes, sir.
So, sir, just by counting the inversions from user 2, We can understand the similarity as the rating is 7 for user 1 and user 2.
Yeah. So this 7. So here you can see what is the minimum possibility is 0. What is the maximum is 10. So you can
10.
check the parameter from 0 to 10. 0 is the exact similar. 10 is the maximum dissimilar. Okay. And you are getting 7. So 7 is coming like this is not actually equal. This is coming after middle. If you are getting like 2, then that is like close to similar. So they actually check. So what you are watching on the OTT platforms, they checks your interest, what you have watched previously and what you are currently watching. So based on your interest, they also checks your interest like with the another user's interest. So which one is your similar? They checks the similarity of by this like this inversion pair counting with this method, and they just check what the other users have watched which you have not watched yet. Okay, so they will give the suggestion to you. You can also watch, try this.
So is there some base case like till this we will recommend that they both have similar interests?
So they just use some additional algorithms. They like set some similarity labels. Like suppose if they set some parameters, if users are getting similarity like which is less than 3 for this example, okay, 3, they will suggest to you. Okay, if similarity is coming like less than 3, so that they will suggest to you.
Rank.
So rank actually, what rank you are get? They will compare the ranks from one user to. So they actually compare the ranks from your rank to the all others users. So which one is the maximum similar? Okay, they will suggest the movie from that user basis because there are lots of users, na? So they will suggest with the each. They will compare with the each, and they will identify that which user's ranking is very much similar to your ranking, and what that user is watching they will suggest to you.
So still just by counting the inversions, how we understand this like the similarity between two users?
This is just a algorithm. Okay, so we set some another parameters for that. Otherwise similarity I'm getting, no? So suppose if I just give the ranking like 1 uh, 1 2 3 4 5 like this, and another order is like 2 1 3 4 5. How many inversion pair in this?
2 1.
Only one, no? This one inversion count is there, and you can
Yes.
see this is very much similar ranking.
Yes.
Okay, so they compare what the previous watching way based on this, and now you can see on the previous history what this user have actually watched. Okay, and what you are currently watching. So they will check of your previous watching with the another user, and based on that, so that means you are very much similar to this user. You two is very much similar to the user one ranking. Okay, now what other this user is watching other than these actually. So this is just like a machine learning type of things. Okay, we are just comparing the history. So what actually user one have watched and what you have actually watched. So now if we found the similarity, now the user one is what other things are watching which we have not actually compared. So that what other user one is watching, so that will also be suggest to you.
So 1, 2, 3, 4. These are actually the ratings some user one has given to certain movie.
So they
And
actually this generally users not gives any rating or anything like so they just identify this ranking based on the interest what you are watching. So they just calculate your interest, so what you are watching.
like the
Okay.
most recent
Huh.
one or the most
So
time.
suppose one user one is watching only action movies. Okay, so they will just notify this and just mark that this user is only watching this action movie. They just categorize the movie in different types, and based on that what you are watching, they will give just ranking some ranking for that. Okay, so
Okay.
what interest they are actually showing. Similarly, user 2, what interest that user is showing. So based on that, internally they actually generate the rank. Okay, that algorithm may be different, but after generating the ranking, how we can compare the similarity? So that we can use this inversion pair.
Okay, sir.
So, what if there are some kind of duplicates? If the user is asked to uh, rank his most favorite movies, then it may be possible that the user
That is a
ranks
simple method.
five.
If this is the simple straightforward method, but generally user not gives the preference that they have no time to for just give the feedback for
That
the
will
film.
increase the ranking.
So they internally calculate. Okay, so that is happens
Plus
differently.
No,
plus plus
what?
plus
Yeah, Mayur.
plus plus will be used. Yeah, increase the ranking of that particular category.
Yeah.
Sir,
No.
I have a question regarding quiz 2. For quiz 2, shall you practice the code as well, or understanding the concept is more important?
For quiz exam code, that concept is more important.
Okay, sir.
Okay, we will not generally ask like what is the code for that, and we know you did not figure out that the what is the implementation for this. Generally, implementation based question not comes in the quiz. Sometimes comes, but that is also very small.
Okay, sir.
Okay, yeah. So just focus on the conceptual parts.
So if two movies are given the same rating, is possible. No?
So rating things we are directly not actually giving. Okay, so they actually generate. Okay, so
User the ratings, no.
user ratings. So what actually they are actually watching. So they can internally they can keep like record. So what type of movie, what you are watching, comedy movie, you are watching action movie or movie theater movie, what type of movie you are actually continuously watching. So they just give some preference like that what you are preferring.
Uh,
Okay,
if the
suppose if you are
user
suppose if in like in one day you are watching three action movie. Okay, and
mm,
like if gives up overall example in like 1 month you are watching like 100 action movie and you're watching only like three comedy movie. So they will just give the preference that you are more focusing on the action movies. So like your first preference is the action movie. Based on that, like they will give the preference.
mm, okay, madam. So if there are two action movies that are asked to review,
So
then
that review thing is different. So generally, that is a different. Every not every user actually gives the review or feedback on if you're watching on the OTT.
Let's move
Okay,
to the
so
next.
so if the two of the movies are the most favorite, then it is possible that he gives priority both.
so now you are much interested on this movie things. Okay, so you can explore this. Okay,
And it's
just
about
explore this how the that
like,
Netflix and Amazon just give the recommendation. Just explore this. What algorithms they actually use? What type of algorithms they use? You just explore this on the your AI platforms like ChatGPT, Gemini. Lots of AI things are there you can do.
no, sir. It's a kind of a technical dog, not a general.
Technical doubt, yeah.
If the two movies are given the same rating by a user, then then how do you compare? How do you
So
rank
this
them?
is I am just giving the example here for one small example like five things or two things. So they actually they give the ranking on different basis. Maybe some they use some characteristics not by only one user. They just combine the users, okay, and then just give the preference. So maybe some different algorithms may be different, maybe there. So that I also don't know what Netflix is actually what actual algorithm they are using. But to after getting the ranking, how they can compare, this is the one algorithms for that. Okay, so
Okay,
maybe they are using some different things also. Okay,
okay. So this works for only distinct rankings.
huh.
There should be some updates like.
So this is the one algorithm where this algorithm can be used to compare the rankings or compare two different orders. How much that orders are similar. Okay, So now this is the one problem, inversion pair. Now the question is how to solve this. So that part is the most important here. So one thing is, so what we have done here, we have just simply compared this like maximum worst case situation. If we can compare every pair with another pair, so that is the one possible way to solve this. So like 5 3 4 or 5 4 3 2 1. So one way is just take the first value and compare with the each remaining. Okay, then take the second value and compare with the each, third value compared with the each. So this is the naive approach. What will be the complexity for this?
N square.
Okay, so this you have already seen in some sorting algorithms, this type of approach, selection sort or insertion sort, these algorithms.
Yes.
So this takes like n minus 1 plus n minus 2 plus n minus 3, these number of steps, and you will get n into n plus 1 divided by 2, like n square complexity. Okay, but here this problem can be solved with the help of divide and conquer approach. And inside the divide and conquer approach, we can use the merge sort algorithm for this. And we can count the inversion pair. So how we can use merge sort for this? So we have seen this, you can see this example. We have just changed the name for this, merge and count. So the simple merge method we are using here, same merge method we are using. Okay, we are not changing anything. But inside this merge method, we are also counting the inversion. Okay, so because of that, we just mentioned the name merge and count. Another part is simply merge sort, so that we are using same as it is, and but only we are just collecting all the counts at each recursive call, and we are combining that count. Okay, so how that count is happening in the merge process, I am giving some idea of the one level. Okay, suppose you have two sorted order. Here we have the sorted order. So suppose you know that in merge part, you always take sorted list. Okay, and B. Like this is the order one. So here we have 5, 8, 10, 12, okay, 14. And this is another like 1, 4, 7, 9, like 10. Okay, so here this is the order. And now we can figure out that how many inversion pair we have. So this is the A list, or we also call the left part list, and this is the right list. L list, right list. So during this comparison, how the merge actually works. So merge actually takes 0, 1, 2, 3, 4, 5, 6, 7. No, sorry, not 5, 6, 7. 0, 1, 2, 3, 4. Okay, so we takes 2 pointer I and J. So how the final sorted list comes? So that we compare I and J value in both lists, left and right list. So if 5 is smaller, so here you can see ith index 0. We will compare the ith index value and jth index value. Which one is the smaller? That counter will move to the next, and that value will be moved to the final sorted list. So this is the algorithm of merge algorithm. Okay, so merge to sorted list. And during this process, so here we will directly count the number of inversion. So how we will count this? So here you can see 5. This is coming in the left list. Okay, so you know that how when we divide the list, so we don't change the order. Left elements will remain in the left, and right elements will remain in the right position side. So 5, here you can see 5, and this is 1. So when you are getting any element on the right list which is smaller than to the left list, so we will check the count here. Okay, because this is not in the correct order. So 5 is coming in the left, and smaller 1 is coming in the right. So that order is means mismatch. So at the time we will increment our count. Here we will not compare with the each element. Here we will directly calculate. So here you can see total 5 elements are there. Here also 5 elements are there. So 1 and 5, you find one mismatch here. Means right list value is smaller. So in this case, we will check only the count things. And we will count this by, so 1 is mismatching with this. So one inversion count is there with this 5 and 1. But how many elements are coming before this? That will also not before this, sorry, after this. that will also make a inversion with this one. Correct? Because 5 is greater than 1. So after 5, what elements are coming on the left list? That will also create a inversion with this one. Correct?
Yes.
Okay. So here we will not compare with each element. So 1 with 5, 1 with 8, 1 with 10, like this. We will not compare. For one comparison, we can conclude all the inversion with this one. Okay, so how we will do this? So when we are comparing this, so 1, and we found that 5 is greater than 1, at that time we figure out that how many inversion count is possible with this one. So for this, current index of I is 0. What is the maximum size of this is 5. So 5 minus 0 we will calculate. Okay, so 5 minus I value current, like this. So we have total 5 inversion with this one inversion pair. So we will directly increment our inversion count by 5. Okay, suppose if we are maintaining count in one variable for this, so we will directly by plus equal to 5. Okay, directly increment with 5. And we will do our process. So we just compare a single element, but we figure out 5 inversion count for this directly. Okay, so this one element will come here and our inversion count become 5. Now next comparison will happen 5 with 4. Okay, because this value is now moved to that, so J will move to next index. Again here you can see, so 5 and 4, again a smaller value is coming on the right list, so that this is making inversion pair. So if this is making inversion pair with these 5 elements, so this will also make with all the remaining element up to this. So same things again, so this will make again plus 5. Okay, so we still I at the 0, so 5 minus 0 is again 5. Now comes to the so this 4 is now moved, now comes to the this value. So J equal to now 7. So 7 is smaller than 5? No. Now this time is left value is smaller. So in this case, we will not check our count because this order is correct. 5 is coming before 7. So this is okay. So no problem. So 5 we will move. Now I value is moved here. Now 8 and 7. So you can see again we are founding inversion pair. So this 7 is making one inversion pair with this 8. And this will also make all inversion pair with this the remaining element. So here 5 minus what is the value of current I? 1. So that means directly 4 we will calculate and plus 4.
Yes.
Okay. So now 7 will come. Now we will move to the 9. So 9, 8. Yeah, 8 is come. No inversion pair. So I will move here. And again 9 and 10. Again you can see we are getting inversion pair. So 5 minus 2, 3. So total 3 inversion pair will make with this 9. So 3 will add. Okay, so 9 will come here. Now 10. So 10 and 10. Here, when in the merge sort, if elements are similar, so in this case, we generally takes the left value first. Okay, because of that merge sort is stable. So this value come first. So this will not create any inversion pair here. So again, this will move to here 12. Now this 10. This is in incorrect order. Okay, so I is at 3 and 5 minus 3 is 2. So that means 2 value will add here directly. Okay, so 10 will come here again, and now this is completed and this is the remaining value will come directly. So 12 and 14. So our operation is working happening in the same way like as a merge sort, but in this process we are also counting this. So that means 5 plus 5, 10, 14, and 17 and 19. So total 19 inversion count we found when we are merging these two sorted lists. And final result we will get like this: 1, 4, 5, 7, 8, 9, 10, 10, 12, 14. This final sorted list we will get. Okay, so during this process you can see in the code where we are doing this. So here you can see we are getting A and B two sorted list. Okay. Sorted list. After that, we are setting all counter I, J, K, I for A, J for B, and K for the C list. Okay. And then we are running this while loop. And if I is equal to m means one list is b list is completed, sorry, a list is completed. Now we will append all the element of b. If j is reached at the end, so that means a list is completed, we will append all, b list is completed, we will append all the remaining element of a. Now this condition you can see here, this is the condition when ai is less than bj. Okay, ai is less than bj. So in that case, we are not incrementing our count. The else condition, remaining condition, this condition. Okay, here if this condition comes like bj, okay, bj is less than ai, that means the right list element is smaller than ai. In that case, you can see we are incrementing our count by m minus I. Okay, m is representing the total number of elements in the a list. Okay, and minus I, where we actually currently I, what is the I value currently, so that we will reduce and we will directly add into count. So only by this update we will get our all the inversion pair. And you know that merge sort algorithms takes order of n log n time, so same complexity will be there here. And we can found our inversion count value. Okay, so and each return type you can see we are also returning count value for each part. When we are combining two sorted lists, we are just also calculating our count value and we will return that also. So that we are actually getting in our main call, and in that we are combining all this. Okay, here you can see after when we are performing merging operation, so merge and count operation will return this count value. Okay, so this is returning count value. So in this way we will add all the counts. So what is the count of left half, right half, and when we are merging that, what is the count? So we will add all the count and finally we will get all the inversion pair. So practically you can take some example for this algorithms and apply this, and you will figure out that how that is actually counting during the merge sort process. Okay, without comparing each element. So in this way we can perform this operation in log n time, n log n time. Okay, compared to the naive approach and square time. Okay, I hope you got the idea how the inversion pay count we are getting by the merge sort.
Sir, what is this merge and count doing, sir?
Merge and count is doing the merge process, which we have we are doing in the merge sort process, merge process. Okay, basically merge process is actually performed combining two sorted lists into a one sorted list.
But we have already counted that inversion count above. So why are we doing it in merge count as
Okay, one second. So merge count is this algorithm above one, this one, na?
Yes, sir, that is the merge. So that is, this entire thing is the merging process, merging of
Uh,
two lists,
so
and we are
inside,
also counting the inversion count over here.
yes, but this is one call, na? We are counting on the one call. This is recursive things. We are calling this merge method many times in our recursive function. So each time we are getting the count, and after that we will combine all the count.
Correct, sir.
Hmm.
Sir, so I'm getting confused when I am calling this merge count again and again.
Hmm.
So why are we then looking out for inversion count separately? Because this merge count itself is giving us the actual inversion pairs. So
Where we
why
are
are,
looking, where we are looking separately.
sir, we are adding these three calls, no, sir? Inversion count of a left and inversion count of right, and then
So this is simple merge sort process where we are calling only. Okay. So here this is a simply merge sort process
correct,
where
correct,
we are dividing. You can see we are dividing into half. Okay. So here we are dividing into half.
correct.
So this is a separate problem. This
Okay,
part is
there
a
we are
separate
not.
problem.
Are we not counting anything over there?
No, we are
Actually, we are.
counting. This is actually inversion count, totally different problem. So
It
first
will
problem
still
is started
multiple
from here.
times till it becomes one and then do the merge and count.
So you can see this P is the main problem. Now this become a P1 and P2.
Correct, sir.
Okay. Okay. Now this is the break like this.
Correct.
Okay. Same. This will break again like P11 and P12, and this will break like P21 and P22. Correct.
Correct.
And when we are counting this merge count, we are counting at the when we are merging actually. So this is the recursive call. In this recursive call will return the value at when it will reach at this part. Okay, this part.
Okay, got the point, sir.
Okay, so from this point, when it will reach at the last level, it will actually reverse that, and at the reverse time, this will perform merge and count this operation. Okay, and what value we are getting? So you can take some small example for that, and then you can figure out that how we are getting this.
Yes, sure.
And finally, we are getting this value.
Okay, sir.
Okay, so this is inversion pair algorithm. We can solve this with the help of merge sort by some modification. And next problem is closest pair of point. So this is another example. Like suppose if you have, so this professor have discussed about some game. So where you have two-dimensional space and where the endpoints are there, and we want to figure out that the pair which actually is at the closest pair. We can figure out the distance between that pair is the closest pair compared to the each pair distance. Okay, so here image is not given. Okay. Some constraints are there also there for this problems. So these constraints are like this. So given endpoints p1, p2, pn, find the closest pair. So this is like a two-dimensional space, and points are there. You know that points we have x, and this is y. So each points are represented by two value. What is the x value and what is the y value? So in this way, we want to figure out that closest pair of points. Okay, which points pair is actually closest. So for this question, we have some constraints. So like assume no two points have same x or y coordinates. This is one condition for this. So like this, if suppose if x value is 10 here, so no two points will come on the same x coordinate like this. Okay, similarly for the y. Okay, no two points will come on the same x value or y value. So this is one constraint for this problem. If our problems follow this rule, then we can solve this with the help of our closest pair of points algorithm. So now the naive approach for this, how we can figure out the solution for this. Here you want to find out the 2 points which actually are the closest point in our two-dimensional space.
Sir, as per video, sir has asked to draw one line in the median. Then divide that into two sets.
No, that I'll discuss, but before that I'm asking the naive approach for this.
So compare all the points and see two comparisons.
Euclidean distance you find out, sir.
Yeah, Manhattan distance or
Yeah. So distance we will figure out by that formula, but we have to compare each point, na? Because we have suppose n points. So you have to compare each
N
single
square.
point with the n-1 points. Then you can figure out the all possible distance. And after that, you will figure out which one is the smallest. Then you can give the answer. But this is the same things. You are comparing each single element with the all n-1. Okay. In this way, you will get a total n square comparisons. Okay. So naive approach takes order of this n square times. But how we can do this with the help of divide and conquer approach. So here also we can break the problem. Yes.
So there should be some threshold, no? Like how less should be to say closest, like
Through this. Oh, 1 second. Sorry, what you are saying?
So for saying closest, there should be some threshold, no? If the distance is less than some threshold, then we can say closest, or are we finding So
No,
top two.
how you can set this? We don't know how much closest points can be.
It's a
So
comparative
Yeah.
analysis.
As
Compared
much
to one
as close
person,
you
how
can
much
get.
close is done.
one by one only.
So but we cannot set before that, no? So but closest distance may be very too much similar. Like suppose if any point is like this point, another point is also maybe some little bit set.
So are
Okay.
we like getting these points sorted based on the distance? Like
No, these are just random points. Initially on the input, all these points are random.
yeah, that is fine. But how closest is it? It is there should be some threshold, no? Or are we getting
No, we have to
these
compare.
points?
So we have to compare. No? So we have random points. Suppose if you have 1,000 points in this two-dimensional space. Now,
Yeah.
how you can set the threshold? We are not checking like this is the closest conditions. We are not giving any closest condition here. We actually need to
So
compare. Actually, suppose if one
and
point is taking like distance 1,000, another is taking 500, another is taking 100, another is taking one. So among all, actually, which one is the smallest? That we will figure out that may be one or that
okay,
may be five.
okay. We are getting only one pair.
We want to figure out only one pair which is
Okay,
actually the closest one. So this is actually the algorithm which may be used at the gaming, okay, where we have the game. So like you know that there are many popular games where you can figure out which one. So some notification comes that enemy is closer to you, so that actually they figure out that which points is
These
actually closer to you.
scores are also taken
that
in a closest way.
Sorry, Mayur, what, can you repeat?
If games have scores, then scores are also taken as a closest way.
Yes, yes.
Only
and
one point is closest to the some point.
Score, I'm not talking which things you are saying that for a score, but yeah, general games. I think many like fighting games type where you just interact with the actual real life of fighting. But at that time, they also at the another side they also actually indicate to you some enemy is actually close to you, and that games are actually real time games when actual users are actually playing that game.
But what that means, assume no 2 points have same x or y coordinate.
No, no, no. So this is the condition for this problem. We are not assuming this. Okay, so 2 points cannot be actually if 2 points are, we are assuming this 2 points are not on the same x coordinate. So x coordinate means if 10 value is there, so this is the y value. Suppose x comma 10. So this x may be anything, but here again we have x1 like 10. Okay, so here you can see y coordinate is same. Then this algorithm is not applicable. So here we are assuming that no 2 points, no two or more points are on the same x or y coordinate. Okay.
Okay, sir.
So this is the constraint for this problem. Then we are only taking this problem. So,
so what if two pairs have the same shortest distance, like the distance between them?
same sort of distance, you can return any.
Any?
Huh.
Okay.
Okay, we are just interested on the closest pair of points. Actually, you can either if you are getting two pair with the same shortest distance, you can return any. Or you can return all which have the same closest. So that is the different things.
These are
Okay.
assumptions. Sir,
These
these
are
are
assumption we are taking here. So for this problem. So now this is the problem. Let me open the slide, lecture slide for this one second. So here the images are given. The slides. Week-8. Just pair of points. So here you can see, I think this is the size. Uh-huh. So we have taken these conditions like let's comes to the graph. Where is the graph? This points. Okay, these are some random points we have. Okay, and we are assuming that no points are coming on the same x and y coordinate. Then we are figuring out that. So naive approach, we have to compare each points with the another points, remaining points, and then we can figure out the smallest, like closest pair of points. Okay, that will take n square time. But by this approach, divide and conquer approach, we can solve this. So here we can figure out that we can divide our area into two equal half. Okay, by doing some process. So we are taking all the points here given n points p equal to p1 to pn compute. After that, we will separate all these points like px. So that means we have suppose n points. So we will just sort all the points based on their x coordinates in increasing order. Okay, x coordinate. So x means first value, and we will sort them. Then we will sort the all these points based on the y coordinates. Okay. After that, we will divide these all points by vertical line into equal size q and r. Okay, based on this. So first thing is px and py. You are getting all these two like point list, sorted point list. After that, you are dividing that problem into two equal half, q and r. Okay, and this q and r, again you will break that. So this is the divide and conquer approach. So same means we will divide this points into two equal half until we will get the base case. Base case we are taking like if we will get only 2 points or 3 points in our half. So we can directly apply the distance formula on that 2 or 3 points, and we will get the closest distance. But what is the overall idea how we are solving this? So in the equal half in this process, so that area is like next here. Okay, so after dividing this, okay, when we will reach at the base case, when we will get the like 2 or 3 points, we will start merging process. Okay, we will start the merging process. So we will figure out the shortest pair of point, smallest closest pair of points in the left half, or smallest pair of points into the right half. So in this way we will combine this. And how we are getting this in the one actually level. So that means, so first things, when we will reach at the base case 2 or 3, you can directly apply the distance formula. And in that case, suppose I'm just taking this example, but this will actually come from the like bottom to up manner, like a merge sort process. Okay, so we will start from the base case, like getting the smallest like this. So
Sir, what
suppose,
question can be asked from this?
hmm,
The
what
question can be asked from this.
question is asking that find out the closest pair of points. So any pair which is coming actually closest with minimum distance between them.
So we have to like every time calculate distance of every point.
No. So that we are actually saving here, na? That is the naive approach. Okay, so let me just tell you how we
Sir,
are.
sir, one doubt, sir.
Hmm.
Sir,
Huh.
you are dividing by two halves, sir.
Okay,
Suppose
I'm coming to that. I'm coming to that. 1 second. Let me just give some overview of this. Okay, so what happening here? Suppose we have initially 100 points. Okay, 100 points we have initially. We are dividing that points into 50 points on the left half, 50 points into the right half. Okay, again we are dividing this into a 25, 25 like this. First, we are breaking the problem. So 25 and 25. Okay, like this 12 or 13 like this. Okay, in this way we will reach at the 6, 6. We will reach at the 3, 3. Okay, now we are making this as a base case. 3 points when we are getting, we will start our reverse process. So 3 points when we have, we can directly apply the base case and we can directly apply the distance. So we have only 3 points at this side, left half, on like this. So we can directly check what is the distance between this, what is the distance between this, and what is the distance between these three. Okay, and which one is the smallest. Okay, and this distance we are calculating on the left half, and same time we will calculate the same distance on the right half. Okay, one middle part I am not actually explaining here. I'll just explain later. But I am giving the overview idea here. So from this base case, you can see these 3 points and these 3 points are calculating separately and not interfering each other. So like this P1, P2, and P3 is coming on this part. Okay, and this P4, P5, P6 are coming on this right side 3 point. So now we are just figuring out the smallest distance, closest pair of points only with this 3 comparison. And here this is comparing separately. So you can see we are saving some comparison. If you see total 6, actually 6 points. So how many comparison are required if you have 6 points? If you want to use like
15 comparison.
15 comparison, but here 3 and 3 both are actually happening separately, and this P4 is not actually happening with these 3. So this is total 6. You can see how we are reducing the comparisons. So here, after breaking the problem, we are just reaching at the base case. From that point, we will only get the smallest minimum distance. So from this, we will get the minimum distance at the list. So what minimum distance, which points actually we are getting the minimum distance, we will return back here. And same, we will return back here. So that we will figure out that here. So which one is the smallest point for this region? Okay. So in this way, we will start.
I missed one part, that is around like P4, P5, P6, where we comparing between them. So after that,
So this is the merge process, na? So when we are taking 3 comparison and we are finding out the smallest this pair between these 3 points. Okay, and same from we will get from this point. And there is also one combined process here. So you got the 3 points, like suppose from this side you got the distance, smallest distance like 2. Okay, from this side you got the smallest distance like 3. When we are merging this, so 2 and 3, which one is the smallest? 2. Okay, correct?
yes sir, yes sir.
So we will only check. So here is the actually one.
I couldn't understand how you got 3, sir.
No, I'm just taking the example. Suppose if we are comparing P1 to P2, P2 to this P1, P2, and P3. We have 3 points. This is the base case actually we are taking. Okay, so we can simply check the distance formula between all pairs. So P1, P2, and P1, P3, and P2, P3. Okay, so we will check the distance between all these 3 pairs.
So only one will come, sir.
Only one will come as a shortest distance. So we will just figure out that suppose the shortest distance we are getting between suppose this pair P1 P3 is giving the smaller distance, and we suppose are taking this is taking 2 distance. Okay, we are calculating by the formula and we are getting 2 by from this side, left side. Same things we will do from the right side.
Okay, sir.
Okay, suppose from that side we are getting like 4 is as a smallest distance. So which smallest distance we will consider? This one, 2 is the smallest distance.
Yes, sir.
But during the merging process, there is a condition actually. Suppose we are getting this type of border. 3 points are like here. Okay, and like this 3 region. Okay, we have reached at the base case. Now we have checked the distance between each possible of this side, left side, and same things for the right side. Suppose we are getting 2 smallest distance from here, and from this side we are getting like 4 smallest distance. So when we will merge this, so we will get this is the smallest distance. But there is a possibility then 2 points may be closer on the border area. That may also be closer than this too. Okay,
So we are reducing our comparison.
So we have figured out the smallest distance from here, smallest distance from here, but we have not checked this on the border pair. Okay, so like this point to this point, we have not. Answer may be come at this border point. So for this, now we have figured out that 2 is the smallest region distance from left side, and 4 is the smallest distance from right side. So now answer is only possible if we are getting closer than 2. So On the border, actually, we mark one boundary, and that boundary is actually takes this two distance on the both side, like one from this side and one from this side. So what points are coming in this region on the border? We will only compare those points. Okay.
Sir, but for that we'll have to check the entire list of points now, because we don't know who is closer to that
So
midpoint.
let's show that slide.
I'm still confused. What question can be asked from this?
Question is very similar. You have suppose 1,000 point. Now you need to figure out that closest pair of points among all 1,000 points. This is the question.
What you I'd like to know is in quiz 2, what would be the questions, sir, if it is like this?
No, can you repeat what you are asking?
In quiz 2, sir, how they will ask questions?
You are asking for the quiz actually. No, your voice is actually not coming now.
He's saying for quiz 2, if same topic
No,
is there,
so
what kind
actually,
of...
I'm not explaining for the quiz to here.
No, I'm
Maybe
just asking, sir, how to frame a problem for this?
so that type of these are actually complex example for the divide and conquer. Maybe generally we don't ask some complex question on this. Maybe some complexity we ask. Some maybe we ask some basic idea how this algorithms actually work.
Yes, sir.
So
Yes.
it's a basic conceptual based question we generally ask. We not will ask like we will give all the points and figure out the all closest pair of points. This type of question we will not ask.
Sir,
Hmm.
so how do we figure out the closest point to the border? Do we
So
compare the...
that based on this left side or right side, na? So left side we figure out 2. Okay. Right side we figure out the
closest
shortest
compared
distance 4.
yeah.
So which one is the smaller? 2. So
Yeah.
on border we will check one from this one side, one distance on this side and one distance on this side. So this region actually we will check. So in this region we will check because you can get smaller than this. Okay. What we are looking the points which are smaller than this.
That have distance smaller than.
Distance smaller than this. Okay, we are figuring out the points on this border which actually far to each other smaller than this two distance. So that will become our answer now for this complete region. So because of that we are taking this boundary, because apart from this boundary if we will cross this boundary then distance will not come as a 2. So there is no there is no need to check the points which are coming apart from this boundary, because suppose this point is coming here, this point is coming here, you cannot get the distance less than 2 for this. Okay, so maximum distance we have taken here as a 2 distance. So the points which are coming outside of this cannot be closer to this 2 distance smaller than this. So because of that, we will only check this boundary region. And in this boundary region, we will just apply the traverse process, like comparison process from bottom to down. That points are sorted in the or based on the y coordinates. Okay, so points will come like this. Okay, so here also we will no need to check each point with the all remaining points in this border. So we will also the algorithms is defined here. If we will compare 1 points with the remaining 15 points, so then your task will be done in n log n times, because we will make this process in 15 and 15 constant process. So that I'll show you in the implementation. But this is the basic idea. So let's show me the slides. This part.
Where it is used?
As I mentioned, gaming is the main actually use case for this. So here you can see now we are not taking as the base case. So this is we are getting as the combined base. Suppose this dq is the smallest distance point in this q region. Okay. So this dq, okay, dq, and dr is the smallest distance on the right region. Now next
Hello,
level. Hello.
sir. How the point remains at the border?
So actually our main goal is to figure out the points uh, among all the points, closest distance, closest pair of points among all the points, so that may come on the border area also. So that let me just come to you that point.
Sir,
Okay.
sir, sir, one example, sir. DQ, this side is 5. 5. Okay, sir.
Huh.
DR, that side is 10.
Okay, this is 5.
Yes, sir.
This is you are saying 10.
Yes, sir.
Okay. Huh.
Then you make one
So okay. So
5
this is
and 5.
not 5 and
You
5.
you draw one two lines vertical
Huh.
line.
Huh. So you can see what formula we have taken.
Yes,
Delta
sir.
is equal to min dq, and
Yes,
after this side is 5,
yes, sir.
and this side is also 5.
Yes, sir. Suppose some
Okay.
points fall between these two things. Uh,
Huh. So here you can see there is a possibility that now you suppose if one point is coming on this and one point is coming on this side. Okay, so that may be at the closer than this 5. So because of that, we need to check at most this region, because any points which are coming outside of this, suppose if you can see this point is coming at the closure of border and this is coming outside of this border, so distance will definitely greater than 5.
yes, sir. One more example, sir. 5 and this side is 6, sir. This side is
Okay.
6. Okay,
Okay.
sir.
So
5
5 and
and
this
6.
side is 6.
6. Okay, sir. 5
Huh.
and 5, 10 is coming.
10
Okay,
is
sir.
coming. Okay. So
And
this region is 10.
some point distance in between is 9. So it falls on one side on the 4 and another side on the 5.
No, no,
Will it
no.
become the closest point, sir?
No, we are only interested the point which have the smaller than this 5.
Yes, sir, smaller, sir.
Huh.
But we do not know whatever falls between that range, so 5 and within the 10. It we are considering that smaller than what we have found out. Am I
So
right?
this region actually we need to check now. So on the this region,
Yes,
what points are coming?
yes, sir. In that
We
region,
huh.
nine may be there, which may be bigger than this 5 and 6, sir.
So that will not be considered now. Suppose
But
if we are
how do we know, sir? It is 9. We are considering no whatever falls between that.
so we will check the distance for this now.
Oh, we are checking this.
So we are checking the distance. Suppose this point to this point, we are checking the distance. If we are getting like 10, so this is which is greater than this 5. So we will not
Okay,
consider this.
okay, okay, sir. Okay, sir.
So in this region, what points are coming, we will just check the distance. If we are getting any distance which is lesser than 5, then we will consider that as its closest pair of points.
Okay, sir.
So this region actually here we are only checking this region also for the points, but we are not checking the points which are coming outside of this. We are not comparing this point to this point. So these comparisons are we are saving here.
Yes, sir. Yes, sir.
Okay, so in this way also on this border area also we are not comparing every point. Suppose in this area coming 100 points, so there is no need to compare each 100 points to each another 100 like this.
Sir,
Here
this
also
border is like border we have created like ourselves, means a range of values that are coming in between.
so that we are actually why because of that we actually figure out that px value, px is just the points which are sorted based on the x coordinate. Okay, all the points. Okay, and the py we sort all the points based on the y coordinate. So on based on these actually sorted order, we will just figure out that what so suppose this point is coming some coordinate. Okay, so this border area coming, suppose this is the x region and this is coming at the like x5. Okay, 5 point. So any point, suppose this point is coming at the 7 comma something. Okay, so 7 comma any y, and this side points is coming like this point is coming 1 comma something.
Do one thing now, minimum of x, minimum of y is considered as if given that there is a set of given delta. I have seen in
Huh.
combining.
So I'm just telling you. So suppose this border point which we have used to divide, actually this is just also representing by some x value 5, and suppose we are getting this delta distance as a 2. Okay, so we will only check the elements which are coming 5 plus 2 7. Okay, so this side 7, and this side 5 minus 2 3. So the points which have x value either 3 to 7, all points we will consider in this region, because we have all points that have some x value. So suppose if any value is 1 comma y, so that will not come. If any point is coming like 3 comma something, so that means that will come in this box or area. Any points which have 7 or something, so that will also come in this border. But any points which is coming outside like 8 9 10 on this side, so that will not come in this border. So
Got
based
it.
on this, we will figure out the points which are coming in this range. So this is just a like logical structure we are explaining, but everything we are doing by calculation of the x divide point by x minus delta, x plus delta, like this. Okay, based on that we are separating the point, and after separating we are just checking the comparison process. And here uh, you can see, so one second, distance. So in this area, so here this is also one explanation. So how many points we need to check actually in this border area? Okay, so we just break this region into these blocks. Okay, so like each block is distance, so you can see this complete distance is delta, left side this is delta, this is right side delta. Okay, delta. Now we break this into half of each area. So this is half delta by 2, this is delta by 2, this is delta by 2, delta by 2, in the same way here. So any points which is so how many points we require to check actually here, if any point is coming in this area, so what are the next point possible we need to check here on the cross border? Okay, so that points may become on this region, this part, and this part, this side, this. So after that, suppose if you are just crossing these points, so you are getting more than like delta distance from this. Okay,
Yes.
so same from this side on the cross, actually this side we have already calculated, so no need to check, only the cross side. So like this point, this point, this point. So maybe you are at close to borders. Okay, so this point, this closest point will be on this block, on this block, on this block, on this block, like this. Okay, so by just some like research things, so they have actually calculated some safe position. So if we compare each point with next 15 point, so that is only enough to check. Okay, so 15 points they have taken like 1 2 3 each, like all cells. So one, suppose if you are coming at this one cell, so 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So this region you can may get the closest point. So because of that safer side, maybe you will not get all the 15 points required. Maybe you need to check only 7 or 8, that is only possible. But for safer side, to make this part process as a constant process, they just taken 15 point next point comparison. Suppose if you have 1000 point in this border area, so every point you need to check next 15 which are coming in the sorted order. Okay, our points are sorted order. Okay, so we are just taking on this direction, so that means we our all points are sorted based on this y value. Okay, now we have the point sorted, so we will only check each point with the next 15 points. We will check the distance and we will calculate the smallest distance between them. If that distance is smaller than our delta, then that will become our next smaller. So this process will become our like next process, and that will become our some constant time of operation here. So let's see the that implementation for this, where we are doing this. Where is that? So now in this C, in here we are doing. because we want to make, so first thing we are using the divide and conquer approach. We are just figuring out the left part and right part, and after getting the smallest distance on left and right part, we are also checking on the border part. So this comparison we are taking by this loop. Here you can see this part. Okay, so we are just checking the minimum distance from S0 and S1. Okay, min S. After that, for I in range 1, size of S minus 1. For each point which are actually on coming on the border, we are comparing with I plus 1, next I plus 1 points. And then we are calculating min S and distance of Sy and J plus 1, which and J we are getting next from next 15 points. So among that we are calculating. So this loop is actually not a n square loop. Suppose if our all n points are coming on that border, we are taking that worst case situation here. Suppose n points are coming all in this border area. Then if we compare each point with the all remaining n point, then it again become a n square. So we don't want this actually. So here this loop is actually work like, suppose if you have total n point, okay, suppose 1000 point. So here loop is running like for each 1000 point, this loop is running 15 times only. Second inner loop is running 15 times. So this will become n into 15, 15n.
Why we have considered 15?
Because our closest point can come with this 15 comparison, or outside of the 15 comparison, our closest point cannot become.
But
So
15 is only
so you
calculated all
no
the big
this
scenarios.
so this 15 is taken as a safer side. You can take less also, because as I saw you that slides na, so this one. So here you can see if any points is coming in any block. So this is the area where we are looking actually, correct? Delta this side and delta that side. So if any points comes like here, so and we are looking the points which are closer than this delta. So how much far that another points can come on this area. So this side it cannot become correct, because we have already figured out this smallest delta distance on this side, left or right side. We have taken the smallest one.
Is where we are using 15.
15 we are taking, suppose if you have like points, all these fields are point, okay, in this region all points are filled. So each points will be compared to the next 15 points which are coming in this region.
In the region where
Region only. Yes, in this region all these points we have sorted based on the y value, y coordinate value. Okay, so suppose this is coming here, next is coming here, next is coming here, next is coming here, like this. So next we will compare the distance, we will calculate the distance with each next 15 value and figure out the smallest one.
What if the 16th value is lowest then?
How it is possible?
Like we have so many of points there that is matching, like in multiples they have been calculated.
That is
We have
not
to
possible.
of
You
the
can
game.
see, you can see how many is possible. Suppose if one point is here, another point cannot be come here. This is not possible, because we have figured out this delta distance on is the minimum distance on left or right region. So 2 point cannot be come closest to this on the one side. Otherwise, suppose this is the like delta by 4. So how we can get this delta? Okay, because this should be minimum on the left side.
Sir, why
So
are we comparing 2 points on the same side? We were supposed to compare it.
so that is the one thing. We no need to compare the same side, because that is already calculated. Smallest things we have already calculated on the left region or right region separately. So no need to compare with the left point to the left point. Okay, we only need to check if suppose this point is coming here. So for this left, if point is coming on the left side, so we need to compare only the right side points which are coming next 15 or 10, any points. So because of that I said this 15 is not like a fixed number, you can also take less, but this is for safer side they have taken. and to make this process like linear process. So your process will become a 15n process, not n square process. So 15n, what is the complexity for this is big O n, correct? If we have 15n steps, so this is a n may be anything. Suppose if n is 1000, n is 1 million, still this part will be remain 15. So this is a constant part. Complexity we will consider as a big O n for this.
So we can take any other number, like not only 15.
15, but 15 is the maximum possibility they have taken. Okay, you may also get the answer only if you take 10. That is also possible. You can also
So we
ignore.
can check based on the length, number of points we
Is
have.
there any logic behind it that is 15 is taken? There is any logic
Um,
ki 15 is the only like we are
Ha,
getting
so,
matching.
so 15 they have actually taken based on this cell actually. Okay, this square cell. They have
If the
just
cell is
considered this.
bigger,
Huh. So they
cell
have
is
taken.
bigger.
Hmm?
If this cell is bigger than 25,
25 means.
if this cell is not limited to this cell that is being highlighted,
No, this is the possible. Na? Delta y2, you can see delta y2 is the each block. Okay. If any point is coming in this region, so smallest point may become like delta distance to this. Okay. So delta like we are only focusing the points which are coming less than delta.
so every time we just consider a particular cell. You mean to say that, like, sir, means you mean to, we have considered a whole page
Hmm.
into a small cell where we are
No,
considering.
no, no. Whole this border space we are only looking. Okay. So this region is only delta on left, delta on right. Only this one. Any points which are coming outside, we are not looking for that. So in this region, actually, you can say no points can come in the like closer to delta distance. As I said that this 15 number is not actually like is it just exact calculation. As I said, this is just to make this process linear, and they have taken 15. This can be, you can also take less 10 also, that your problem will also be satisfied with this, but complexity will remain 10n. So it will not impact the complexity if you are taking 10n or if you are taking 15n. But here our main target is to become this second part as a constant part. So they have taken 15. Also, if you will see closer to this, 15 is not required. 15 is also not required. But suppose if you take 7 only, so 7n will become. But still, this is complexity is n. For big n value, this 7 is not much actually impact on the complexity. 7 or 15. So there is no, actually, they are not changing any complexity for this. Okay, so here if first things, they are actually comparing each points which are coming in this region. They are not actually in the algorithms, they are not checking this process. So if we are comparing the point on the left side, uh, if our point is coming on the left region, so in algorithm is actually they are not checking. If another point is also coming in the left region, so they also not need to check, because that calculation we have already done in the one side region. Okay, so we only require to check only one point which is coming on the left side. That point should be checked the point on the right side points. If any points are coming on the right side, that point should be checked on the left side. But how much uh, points we need to check, they have just taken one fixed constant number 15, and that is enough to make this process linear.
Okay, sir.
So 15 points, suppose if you fill all the points here, okay, that is not possible because like I'm filling all the points. This is not the possibility actually, because if we are filling all this area, so this is not possible. This you will not get this delta actually. Okay, because delta is the points which are the closest on either left region or right region. And if we are making these 2 points like each cell, so this is less than delta. So this region should be, this is not correct then. Okay, so but they have taken like based on this. So each point will should calculate the 15 points. But that is actually some additional work, but that is not impacting the complexity. Okay, so in this way they have just make this part as a like constant linear part, so that big O n, this part. So because of that, our complexity is overall remain n log n. Otherwise, if we compare each point with the remaining all the points, so worst case complexity may actually happen again n square. We compare each point with the remaining on points. So that loop will actually become a n square loop. So we are just making this as a linear loop by making the comparison with the constant number of points. Just think about closely here how this point actually comes. So delta is taken as a smallest distance on the left region, or compared to the left region or right distance. So that means no points can come less than delta distance on this region, left side region. Maybe come on the right side region. Maybe suppose you got this delta like 2 value on the left side and 10 value on the right side. Okay, and based on that you figure out that this 2 value is the delta value. So 2 this side and 2 this side. Okay, so you may got on this left side, you there is a no point which is lesser than 2, because that you have already calculated, but this side is the smallest point distance was the 10. So here you may got the lesser than 10. Okay, maybe some points are coming but still 2 on this side and 2 on this side, but still same things, no points can come less than 2 this side, otherwise that become a smaller delta. So distance will still remain like this 2 points value cannot be less than 2. This cannot be 2 less than 2. Okay, any points on the left side or right side cannot be less than 2, because that we have calculated. But the border area, this distance may be less than 2. Any points like this. So because of that, we are checking this border area. So because of that, we figure out all possible regions. Suppose any point is coming here and another point is coming here. Okay, so this distance is more than delta actually. Okay, and maybe one point is coming here, another point is just coming on the board this side. Okay, so there are many possibility of that, like in this region maybe closer. If any point is coming here, so that may be closer than this, like this. So you can see what is the possibility, how many points may come. So that is not more than like 15 is very large value we have taken, but you will figure out that 15 is also very large. Okay, this may be if you are checking only the cross region, that this value maybe is possible only, like suppose if any point is here, so what point can come, okay, with the less than delta distance? So either this side, or we are just looking for the sorted side thing. Okay, so this area it may come, okay, in this cell, but this also can be in this cell. Okay, this may this, or maybe this. So I think if you are looking bottom up order, so maybe 4 region is enough to for the cross region. After that, distance will become more than delta. Okay, so this region, if you are only checking cross region, okay, left point to the right region, or point to the left region, then I think next 4 point is enough to check. Okay, but this is just make as a safer side. 15 if we are making that, our complexity is still big O n, so that will do our work with the same complexity. Okay, so this is the closest pair of points. Next algorithm is one second. This integer multiplication. How we can solve this? So if we are multiplying any integer elements, so what are the number of multiplication required? Okay, so here we are just taking this n value as a digit value. How many digits we have? Suppose if we have 1, 2, 3, 4, and we have the number 5, 6, 7, 8. This we have number A, and this we have number B. So naive approach actually multiply, if you multiply each number by each digit. Okay, so like 4 digit we have in the both numbers, so 4 into 4, 16 multiplications are required for this. So in this way, big number, how we can reduce this multiplications. Okay, so this is the naive traditional method. N square is the complexity. Here n is representing the number of digits. So naive approach, divide and conquer approach takes n square still in the, but Karasuba algorithms takes this complexity, because n log to the power 3. Okay, so that is n to the power 1.59 something. So this reduce the multiplications by just replacing some multiplication to the simple addition or subtraction operation. So how that actually works? So suppose a and b, we have this number. After that, we break this actually half of each. Okay, so initially, suppose this, I am taking a small example, only 4 digit, but this number may be bigger. Okay, like 16 digit each. Then we can break this. Okay, so divide and conquer approach, this break this big digit number into a small digits number. So we will just divide this process till the base case. If suppose here you can see base case what we are taking, if for n is equal to 1, so 1 means single digit. If we are reaching at the single digit, we will directly multiply. Okay, that is a single multiplication operation. But before that, we will just break this problem into a like sub problems by divide approach. And how it actually works, okay, how we reduce the multiplications. So let's take this, how we can break this. So we will just break this number into two equal half, so 12 and 34. So we can just write like, suppose a value is 1 2 3 4, okay, and b value is 5 6 7 8. So now we will make this as a1 is 12, okay, and like a0 is actually 34. Okay, similarly b1 equal to 56, and b0 equal to 78. Okay, so we just break this problem into these problems. The name multiplication, how this name or how we can write this actually, with the help of these two numbers, how we can make the a. So that we can make like with the help of this uh, a1. So we can make like this, a equal to a1 into 100, 10 to the power 2. So where this 10 to the power 2 is coming, because we have 4 digit here, initially we have 4 digit, and we are breaking into two digits. So because of that, we are taking this 2 value here. Okay, so if we have 8 digit and we will break into 4, so this 10 will become a 10 to the power 4. Okay, so how much digit we are actually breaking, so that value we are taking, plus a0. Okay, b we can write like b1 into 10 to the power 2 plus b0. Okay, so this is the way we can write this, and we are multiplying this a and b. So we can just write this expression like a into b, and we can write this. Okay, so we will write like this, a1 into 10 to the power 2 plus a0. Okay, and this multiplication with like b1 into 10 to the power 2 plus b0. So this multiplication we have written here. After multiplying this, if you come write these steps, so let me take this value as a k. So I'm just not writing this 2 here. So for general expression, I'm just writing this as a k. Okay, so just consider this as a k. Sorry. K, and this side also k. Okay, the k is equal to 2. So just multiply this, you will get like this operation. So a1 b1. Okay, just multiply all each steps here. So a1 b1 and multiply 10 to the power 2k. This will become like this, and plus here internal steps will become like a1 b0 plus a0 b1, and remaining part will also remain the so here you are getting this multiplication. Okay, a1 b1 multiply 10 to the power 2k, and a1 b0 a0 b1. Okay, here multiplication will come, so 10 to the power k and plus a0 b0. Okay, if you multiply both this part, you will get this expression. Okay, I've just expand this. So if you write a1 multiply this b1, okay, so you will get a1 multiply this b1. Okay, you will get this expression when you will multiply this both part. So in this expression, how many multiplication you are getting? So you are getting okay, I cannot scroll down. Okay, so I'll just check, open the notepad. Okay, so I'm just noting down this on our notepad page.
6.
Huh? A1, B1. Okay, how many multiplication I am getting in this step? So sorry, not this, sorry. So I'm getting A1, B1, another is A1, B0, A0, B1, and A0, B0. So four multiplication you can see we are getting in this expression if we are performing. That is the requirement. But how we
So
can, huh?
what about into, like into 10 to the power 2k?
So that is just a common operation. How we want to reduce this 4 operation to 3 operation. So that actually Karasuba is doing. So how that Karasuba is reducing this 4 multiplication to 3 multiplication to reduce the operation. Okay, so that is just a, some constant operation, so that can be solved. But we will reduce this 4 steps to 3 steps by just using some addition or subtraction process. So how that we are doing? So we are taking like
Or can be
one
added.
P1 can be written like as A1 and B1, and P2 is just we are taking as A0 B0. Okay, and P3 we can write like as A1 plus A0 and multiply with B1 plus B0. Okay, so this is simple addition process. If you multiply this, so what you will get? A1 B1 plus A2, sorry, A1 B0 plus A0 B1 plus A0 B0. Okay, so I just multiply this, and after that you can see what are these additional remaining steps. So A1 B1 we have taken this, A0 B0 we have taken this. So A1 B0, you can see A1 B0, this one. Okay, and A0 B1, A0 B1. So this part we have taken, and what are the remaining part? You can see we are getting A1 B1. So this is P1 actually, and this part, this is P2. So I can write like this: if P3 sorry, P3, I can write like this. So I'm just trying to calculate like this operation. Okay, so this operation. So what this operation will be actually P3 minus, so
P1 and P2.
P3 minus P1 plus P2.
Bracket. Yeah.
Yeah. So this will become your A1B0 plus A0B. Okay. So this value you are getting by this operation. So here you can see we have reduced uh, this operation to multiplication A1B0 and A0B1 by this operation P3 minus P1 plus P2. Okay, and this actually we will just put in our actual expression. So this expression we are getting, so we will just put this expression here. So A1 B1 is representing P1, and into 10 to the power 2k plus here we will write like P3 minus P2 sorry, P1 plus P2. Okay, this multiply by 10 to the power k and plus P2. So now you can see we have only these three product. So P1 and P2 and this P3. P3 is single this product. Okay, this is just simple addition. After addition, we are doing this product. So after getting this three products, so we have converted four product into a three P1, P2, P3 product. So this is the basic idea of the Kurosawa algorithm. So we continue recursively. We required a 4 product, okay, but we reduce this recursively into 3 product. So that is actually saving our product operation. So
Sir, how much time complexity reduced?
so this is now actually reducing into 3 calls. So if you see the recurrence relation for this, so that is actually this one. Total 3 recursive calls are there. So tn equal to 3tn by 2. Each time we are dividing our total number of digits into half. So because of that, this is n by 2. And each time we are processing this n steps. So this recurrence relation become like, oh, 1 second. I'm just moving this. Okay. So we got the recurrence relation for this Kurosawa algorithm, that tn equal to 3 recursive call. Each time we are just calling tn by 2. Okay, 3tn by 2 plus n is additional steps it's required. So for this, we will calculate the complexity, and finally we someone raise the hand. Yeah, Kimras,
Yes, sir.
you raise the hand. Do you have any
Mr.
query?
No, sir.
Okay, okay. So this is the recurrence relation we got after this process. So if we solve this process, so that we will get the complexity n to the power 1.59 something. So that we will see that how we calculate the complexity for
This
this
is the
type of
last
recurrence.
topic for today.
How many topics are remaining? Quick
For today.
select, quick select, and recurrence relation. Those 2 topics are remaining. Okay. So let's quickly. So this is the complexity for integer multiplication. Let's quickly discuss the complexity recurrence relation, which is important for week actually 8. Sorry. So how recurrence relation actually we calculate the complexity? So with the help of recurrence tree. So this. One second. Sorry. Sorry. So I'm just skipping this quick select algorithm. You can just visit through, go through this in the lecture. Otherwise, we will discuss in the next week in the revision session. So I'm coming on to this recurrence tree method to calculate the complexity for recursive functions. So here, how we can calculate the complexity. So we have already seen this method before when we calculated the complexity for merge sort, quick sort, recursive function. But how we can figure out this? So here actually for the complexity, any recurrence relation we can compare to this method, like this
So this
form
will be
T.
the last topic for today.
This is the last topic. Okay. So Tn equal to, and this is important maybe. Okay. So one question you can expect from this, you will get a recurrence relation and you have to calculate the complexity for this. So Tn equal to R. Okay. This R is represent how many recursive calls you are doing. Okay. And this is the next call complexity, so that n by c and plus fn. Okay, so just compare your recurrence relation with this recurrence formula. Okay, so here what is the value of r? So in the previous method we have seen this tn equal to 3t n by 2 plus n. Okay, so we got this for Kurosawa algorithm. So here, what is the value of r? So this is represent total number of recursive calls at each time.
What
So
is
that is
n upon c?
n is the total input. N is the input of the problem, and this first value before which we written before the t, that is the total number of recursive calls from that function. Okay, that recursive function. So we are getting 3 recursive calls. Okay, so r value is
Yes, sir.
become 3 here. Okay, just note down this, and c values represent how we are actually dividing our input in our recursive calls. Okay, in what factor we are dividing. So initially we have the input n, but in our recursive calls we are just passing n by 2. Okay, so
Sir,
by
F is also there, no?
f, sorry,
Yes, this F and is there any function given?
no, this is actually represent what other time apart from recursive calls, what your algorithms taking the additional time. Okay, apart from the recursive calls, so that is the time actually represent. Fn is representing n here for this. Okay, so r equal to 3, c equal to 2, and this fn equal to n. So this fn is represent the time, running time for the remaining part apart from the recursive calls. If you just see any recursive algorithms, so there are some recursive area where you are calling the same function again. So how many calls you are doing? So that is coming here as a value of r. But each recursive calls, how much input you are passing, so that you are just taking by n by c, like in which ratio you are dividing the problem. And apart from this recursive calls, the other part of the code, what is the complexity for that part? Okay, so that is represented by fn.
Sir, C is still unclear. What is C?
Okay, so just remember the merge sort algorithm. So merge sort algorithms, what was
Okay,
there?
okay.
So Tn, okay, we have initially n input, but in the next sub problems, we divide our input into half half. Okay, so n by 2 at this level, n by 2 at this level, correct? So how we are dividing our inputs in each recursive call. So what factor we are dividing, that is called as a C. Okay, so just compare your recurrence relation with this expression Tn equal to Rtn by C plus Fn. Okay, so what is the R value, what is the C value, what is the Fn value? After that, just create this tree. Okay, so I'll just make the recurrence tree for merge sort, and I'll show you how this. Let me write here.
So what is C?
C is the factor we are dividing the input in the each recursive call. Okay, so merge sort, we write the recurrence relation like Tn equal to 2Tn by 2 plus n. Okay, this is the recurrence relation for merge sort algorithms. Means in each merge sort algorithm, we calls the merge sort recursive calls 2 times, and each times we are passing the half of the input. Initially, this input was n, and we are passing half of the input, n by 2. Okay.
Merge sort is working O. That is best case is O n by
No,
2.
always n log n. Complexity always is n log n for merge sort, and this is the recurrence relation. So you know that na, if we have like initial, suppose n equal to 8 element, we have that first call. Okay, so next call our elements are divided 4 and 4, correct? In the next recursive call, this will divide 2 2, this will divide 2 2, and next it will become 1 1. So
Yes,
every
sir.
time we are dividing our n input by 2. This is the actually C value for what factor we are dividing our n in the each recursive call. So means our next recursive call, what is the input actually, and that input is just compare that input to the previous input. So how that is actually reducing. Okay, so here what is the R value? 2, C value is 2, this value, and Fn value is n. Okay, so now comes to the recursion tree for this. So recursion tree we draw like this. So Tn is the main first call. After that, this become a Tn by 2 first call and Tn by 2 another call. So this is a new problem. And apart from that, we are getting n additional times. When Tn is there, n is the additional time. When Tn by 2 is there, then n by 2 will be the additional time. Okay, additional steps we are getting. Now it will become T n by 4. Okay, T n by 4. This is also T n by 4 and T n by 4. Just draw this like this. Okay, not completely, just make 2 3 level, and you can figure out that how your operations are at each levels, how they are actually affecting. So in the first level, you are seeing this level, you are saying n steps are required apart from the recursive call. Okay. Here, if you add these both, okay, at this level, second level, if you n plus n by 2 plus n by 2, it will also become n. Here, additional step will be n by 4, n by 4 plus n by 4 plus n by 4. Okay. If you add all these, n by 4 multiply 4, still remain n. Okay. So in this way, you will see at each levels, our steps are n. So here, if you are getting equal steps at each levels, so we can write our complexity directly, complexity like as a fn log n. So what is the fn value you have? Fn value is
How
n.
log n is considered, sir?
Huh?
Log n,
Height
because
of
it,
the tree.
please
Height.
wait.
Height.
Uh, no, height is considered, but in some math term is 1 upon n, right? 1 upon n we are considering as log n, right?
1 upon n means?
Like in differentiation also we put like log n is 1 upon n always. So what was the conditions for like writing log n always and a height is considered? Like where we can like in recursive calls also we use log n recursive call. So there is it not a tree na tree where we use log n. Here log n
This is a tree.
consideration.
This is actually a tree.
It's like 2 power something is giving n. So that's
This,
something
this is
given
actually
log.
tree. Each time we are dividing our input as a half. So if you will just consider this as a half time, okay. So you will reach at the log n steps to the one base case. So n by 2, n by 4, n by 8, and you will reach at the one in log n steps. So total log n levels are there in this tree. So that means each levels you have equal effort actually, and this is not increasing, this is not decreasing, and total log n steps are levels are there. So simply all steps will be log n multiplied by n, and this is the direct formula. If you are getting equal effort at each level, simply use this fn multiply log n. So recurrence tree, like condition is mentioned here. You can see you will get these type of three common cases. If your that effort on each levels are actually decreasing or equal or increasing, okay, based on that you can directly write the complexity. If equal, you can see you can directly use big O fn log n. What is the value you have fn? Suppose if this fn value is n square, then you can directly write n square log n. If your operations are fixed at the each level, you can directly use this formula. If this is decreasing or this is increasing, so what are the case we can consider for this? So let's see the example for quick select, which is not covered today, but I am just explaining the recurrence relation for that. Okay, this I'm taking, sorry, this one. So for quick select, our recurrence relation is Tn equal to Tn by 2 plus n. Okay, so this is the quick select recurrence relation. This n is required for partition process. Okay, we also use the partition process in the quick select method, but after partition method we only use the half of the part. We completely discard half of the part. Okay, so here this is n for partition process. This is considered as a fn here.
Partition process.
Partition process, like a quick select. A quick select is a different version of quick sort. So partition
We are
process.
selecting the pivot here, no?
Pivots are correct. So that same steps we perform in quick select also, partition. But after getting the pivot element after that pivot position, we discard half of the part, either left or right. Right. We only consider the remaining half. So because of that, only one call is there in this quick select. So that is only Tn by 2. So here R is only 1. Okay, and C is 2, and Fn your this n. So if you draw the recurrence relation for this, so this you will get only one steps at each. So here Tn is there, but next step t n by 2, next is t n by 4, like this. Okay, t n by 8. So here additional step is n, this will become n by 2, this will become n by 4, here n by 8, like this. So if you are getting this type of order, if your effort is decreasing by some factor at each level, in that steps you can directly consider this as a complexity. Your complexity will become big O Fn. Okay, so this is the according, you can see if your this is decreasing, you can directly write the complexity Tn equal to big O Fn, because root dominates the sum here. If you will calculate the sum, so you will get a constant time of that same root value, Fn value. So in that case, you can directly consider your Fn as a complexity. If this is an increasing, okay, if this is increasing, so we use this formula. Here you can see Tn equal to big O n to the power log base Cr. So this is the another formula if this is increasing. Suppose let me just give the example for another recurrence relation. So Tn equal to 4Tn by 2 plus n. Okay, here this is supposed recurrence. So here you will get 4 as a R, and C equal to 2 and Fn equal to n. So if you make the tree, so Tn, there are 4 calls here. Tn by 2, Tn by 2, Tn by 2, Tn by 2. Okay, here n steps are there, but here for each is n by 2. If you add n by 2 plus n by 2 plus n by 2 plus n by 2 4 times, so means 4 into n by 2, so you will get a 2n. Next time it will become 4 for each, so that will n by 4 actually. So 16 times n by 4.
4n.
Okay, so this will become 4n.
4 by n.
So or you can also write 2 to the power 0, 2 to the power 1, 2 to the power 2, like at each steps. Here these steps are increasing. So in this case, we will calculate our complexity directly by n to the power log base Cr. Okay, big O, like this. So big O n, here what is the log C value? C value is 2, base 2, and R value is 4. So we can write like 2 to the power 2. So this will come here, and this will become 1. And overall complexity will become big O n square for this. And for Karasuva algorithms, if you follow this, so Tn equal to 3Tn by 2 plus n. So here R equal to 3, and this C equal to 2, Fn equal to n. Now if you make this as a recurrence tree, this will also increase at each level. So Tn additional n, then it will become 3 call. So each is n by 2, n by 2, n by 2. Okay, if you add, this will become 3n by 2. Okay, which is greater than this, correct? And next step, this will become 9 n by 4. Correct?
Yes.
So each time it is increasing actually. So in this case, use Tn equal to n to the power log, what is the value of C? C value is still 2, and this is 3. If you calculate this value, you will get n to the power 1.59 something. So that is actually complexity of Karasuva algorithms. So
It's for Kruskal.
no, Karasuva, this integer multiplication algorithm which we just checked.
Sir, second one, what? How we got O big O n square, sir?
Second one here.
Above. Oh, yes.
Okay, so this is log base 2 and 2 to the power 4. We have written 2 to the power 2.
Yes.
So this base comes before, so this become 2 log 2 and 2. This is actually equivalent to 1.
Okay, sir.
Okay, so because of that, this one is come. So this is 3 way you can check for any recurrence relation. You can just figure out this recurrence tree and see your steps at each levels are increasing or decreasing or equal, and you can directly use this formula. Yeah, Kiran.
Sir, can you solve like this for Fibonacci sequence also?
Okay. So that is actually not a divide and conquer problem. This we use for the divide and conquer problem. Okay, that is actually reduce the steps n minus 1. Yeah, binary search you can use. Okay, so tn equal to tn by 2 plus 1. Okay, so this is the things. So here fn equal to actually 1. 1. Okay, and r equal to 1 and c equal to 2. This is steps. But if you see this tn, this is divided into tn by 2. But this time actually we can consider that tn by 4. At each time steps are 1. Additional step is actually 1. This is constant. Okay. So this
What
is
is
actually,
the
sorry,
what is the best method today
best method for which?
for better searching?
Binary search, no?
Yeah, any search.
No, what you are asking, I'm not getting.
What is the method for best search? Means any best search method is.
No, that is depends on the input. If you have that like sorted order, you can use this binary search method for searching. That is the best. If you have unsorted order, definitely you have to use linear search. Okay, searching we have only this best algorithms, binary search, but the requirement is our data should be sorted. Otherwise, if your data is random, you have to definitely apply the linear algorithm.
What algorithm, sir?
Linear search algorithms, naive
Linear
searching.
search. Linear
Huh.
search.
You have to
The
compare
data
each
is
element.
complex, then
Sorry, your data
if the data is too much heavy and complex, then
again depends on it is sorted or not. If it is not sorted, definitely you have to apply the linear search. If
Sir,
your data,
linear search, big O n square, sir.
no, big O n. Linear means n.
Okay.
If your data is sorted and your data is very big, then definitely binary search is very efficient. So for this, actually, you can see each level steps are same. So we can directly use fn log n. Okay, so fn value is 1, 1 into log n, and we will get log n complexity for binary search recurrence. Okay, so this is recurrence tree method to calculate the complexity for divide and conquer type of recurrence relation where you are using this. So this type of questions may come. So just you can remember all these three steps. If your steps are increasing, then what should we do? And you can directly apply this formula. Okay, fn log n or fn for if your decreasing steps are decreasing, directly take fn as a complexity. If your steps are increasing, then use n log base cr. This.
Sir, sir, in one of the PYQ, I saw fast select, sir. What is a fast select, sir?
So that is one remaining. So that I have just discussed. So quick selected, fast select. So that one topic is remaining for the today week-8 content. So fast select, actually we are figuring out the kth largest or kth smallest element. I'm just giving the basic idea of that. How actually that quick select is, what is the fast select. So that actually works on the quick sort method. So suppose if we have any random order, okay, it's like I'm giving the random order 5, 3, 1, 6, 2, 8, 9, 7, like this. Okay, this is a random order, and I'm looking for the element, third smallest element or third largest element. Okay, I'm just looking third smallest element, k equal to 3. And how we can find out this third smallest element? If naive approach, you have to compare each element to another elements, then you can figure out the third smallest element. Or you have to run this algorithms like at least 3n time, kn times, but worst case still will remain n square. So, but for quick select method, we apply the same quick sort method. We apply the pivot, partition method. So suppose we are taking this as a pivot element, and we will perform the partition method. So after partition method, so this actually will come onto the correct position. So like sorted order is first position, second, third, fourth, fifth, sixth, seven. How many elements? 1, 2, 3, 4, 5, 6, 7, 8. 8. Suppose we have 8 elements, so this 5 will come at this position. Okay, and partition process 5 will come at the correct position. Before that, all the initial elements like 3, 1, and
So
okay,
5 will be at fourth position.
fourth position. Okay, here we have only, so this will come at this position 5, and you will get like sorted, all sorted element before this, and the all bigger element compared to this will come after this. Okay, so that is just like a 6, 8, 9, 7. Okay, so all these are actually bigger elements. So this is the partition process. So this actually guaranteed that this is the, after getting the correct position for this pivot element, you can say this is the fourth smallest element. Okay, first smallest will come at this position, and fourth smallest will come at the this position. Okay, so we got the elements which is coming at the fourth position. We can say that this is the fourth smallest element, and what we are looking for, third smallest element. So definitely third smallest element will come on this left side. So we will discard this part completely in our next process, and we will only look this side. So this is the way. In quick sort algorithm, we apply the quick sort on the left or right part, but quick select, we discard half of the part. Okay, after getting the pivot position. If our kth position, suppose we are looking for the k like sixth smallest element, then we only look only this side because we got the fourth smallest element, and sixth smallest element will come after this, not the before this. So at that time we discard the left part. So this is the idea. The same algorithm we will apply again on the left part, and we will discard the right part. So that because of that, we only calls recursive this on the one part. Now you know that quick sort worst case situation is n square. Okay, that is the case if our pivot element is always coming at the corner side, either first or last. So that is the worst case situation for quick. In that case, complexity will become order of n square. Here also same situation may occur, and complexity will become order of n square here also. Okay, suppose if your pivot is coming at the first position every time, okay, in that case you have to repeat the same n minus 1 n minus 2 like this operation, and your complexity will become n square. So how we can improve this? So because of that, we have one algorithm MOM that actually calculate the one good pivot that will never come on the corners, that will always come approx middle positions. And this MOM algorithm is a big O n algorithm, median of medians. Okay, so this MOM algorithms provide a good pivot that will all in order of n time. So this is also not increasing the complexity. Okay, in order of n time, we can figure out a good pivot element, and that pivot element will always come in between, not at the corner. If this is the case, our complexity is improved, and that will become n log n for quicksort worst case situation. Okay, that improves our quicksort worst case situation. Also improve here fast select. That is the actually fast select algorithm. Okay, if we use this MOM algorithm for selecting a good pivot in our this method, quick select method, okay, so that it become a fast select, then we will always get our answer in big O n time. Okay, this is actually a fast select, finding a kth largest, kth smallest step, so big O n time, and using this MOM method in quick sort, that worst case also become n log n. Okay, so this is the improvement. So now you can look this MOM algorithm, how this actually works. So we break the all elements into some 5 blocks, and after that we figure out we sort each block separately, and then we find out the median element of each block, and then we repeat the same process again. So if you see the implementation of this, so that actually we not use the loop like n nested loops at n or n, so that will become n square. We run the loop like n or 5. We have already seen this type of case in our closest pair of points situation, 15 into n. Here also we perform the operation of 5n times. Okay, so we compare each element with another 5 elements to sort it. That takes actually 5n times, so our complexity remains big O n for this. Because of that, we achieve this. Okay, in order of n time, we figure out the good pivot, and after that, we improve our like quick sort complexity to n log n and quick select complexity to big O n. Okay, so this just you can look this MOM. This is only the remaining now, so you can just explore this. Okay, just see the lecture. Okay, so this is all about week 8 content. Any query?
Um, in like OPP eligibility, will there be any relaxation? Like I did all this 7 weeks, but like 1 or 2 GRP
Okay,
I missed.
okay, that is a
We
difficult
could
question
do
for
like
us.
best of 6 or something,
Uh,
or maybe have an extra OPP if someone missed 1 week.
I can't say something, but yeah, just maintain your average, good average actually in all till week 9. Okay, so maybe I'm not sure for this, but maybe they give some relaxation, like they will calculate some average for this. Okay, so just maintain good average for this overall average
Sir,
instead
what
of.
we can
Uh,
for
Till
our
now it's 100 only, like 2 GRP I missed. So for
Huh,
that
that is fine, because
one
of
week
that I'm
is
saying
going with.
do not miss anything else. Okay, now, okay, just maintain your average good. I think I'm not sure currently because they have not finalized this, but maybe they will actually provide some alternate for this. They will calculate some this average of all weeks like this. Okay, but I'm not confirming this.
Sir, hello.
Yeah, because this is grading rule. I have discussed this with one time, but they said that this is grading rule, they cannot change. But maybe if this is the case for many students, they will just give some relaxation. So because of that, I am saying just maintain your overall good average
So
in GRPA.
what are you going to relax, sir?
No, there is a one grading rule for the OPP exam actually.
No, sir.
So your score should be greater than or equal to 40 in each week GRPA. So this is the grading rule applied this term. This is applied on each course actually, each OPP course. So this is grading rule. So we cannot.
Sir, but it has not been
For
mentioned in
other
other courses, sir.
other things, it's like best of 6 or best of 7.
They actually they will that main higher authority will decide. Okay, so because of that, I'm saying just maintain your good average now, because I'm not sure they will give the relaxation or not. Okay, so
what
this is
will
one.
be the like what where we can prepare for OPP? Should we
Okay,
only go with
just give me
GRP?
1 second. Let me content part is covered, so I'm stopping here.